Okay, this is Mr. Peterson, and I'm returning to the 2.3a notes, and we're going to be doing page 2 of 4. So I'm going to take a little brief detour here, and I'm going to show you why we're trying to learn this skill. And this is a future skill that I'm going to show you just in brief right now, and I'll come back to this. So factoring will allow us to solve some equations that we couldn't solve otherwise, quadratic equations. So I'll show you where the factoring is in this process. This is something we'll learn later. It's called solving equations by factoring. And what I'm going to do here to start with is I'm going to subtract 11x from both sides. You can see it comes over here. And then this little part here where I take the equation or the expression and I break it down into a multiplication is called factoring. And that's the hardest step in this process, is breaking it into its multiplication. I will be teaching you that, but here I'm just showing you why we're trying to learn this process. Now, once it's on this factored line here, we're going to use something called the zero product rule. If you multiply two numbers and it equals 0, like here we have this times this equals 0, then you can conclude that either the first number equals 0 or the second number equals 0. So anytime you multiply two numbers and you get 0, you have to use 0 for at least one of the two parts. So what happens here is you set the first factor equal to 0 or the second factor equal to 0, and then you just solve. You can tell I added 1 to both sides and divided by 2 to get this answer. Here I just added 5 to both sides to get that answer. So we find the two answers that work up there, and that process required us to know this skill of factoring. So let's begin the journey of learning how to factor. So the first type of factoring I'm going to teach you here is called looking for a greatest common factor. A common factor is any factor that's shared by the parts. So let me show you an example here. This divides by 3, this divides by 3, and this divides by 3. So my common factor is 3. What we're going to be doing here is like reversing the distributive property. We have a multiplication here, so this one's the factored version. If we distribute, we get the following expression. But when we're trying to reverse this process, we have to ask ourselves, what is it that we multiplied by each time? And there's a 3 hidden in there, and a 3 hidden in there, and a 3 hidden in there. So the common factor is 3. And if more than one number divides into these, you want to pick the biggest one. So we try to find the greatest common factor, GCF for short. And we're going to try and reverse this flow. So we use the distributive property to go this way. We want to kind of reverse that flow this way. So just to be a little playful with it, this process you might think of as doing the distributive property backwards. So I'm going to spell distributive backwards. Okay, there's the distributive property spelled backwards, okay? Just to remind you that's what we're doing. So we've got the expression here that we got by distributing. Now let's undistribute. You pick on the small guy first, 3. The only numbers that divide into 3 are 1 and 3. 3 is your biggest, and make sure that it divides into all of these. Sure enough, 3 goes into all of them. And so now you set it up as if you were distributing. 3 times something gives this, and that would have to be 4x squared. You can see that that would give the 12x squared. And then the middle term here has to multiply to give that, so we're going to need 3 times negative 5x to make it turn into negative 15x. and then you go 3 times this last blank has to be 3, and you're going to multiply by 1 to get your 3 back. So we've gone full circle with this. This is like distributing and then undistributing, and we're back where we started. I'll do one more like that where I go both directions. Here's the answer we're going to end up having. We'll distribute here, and that gives 4x, it gives 12x to the third power. The second one here gives negative 4, and you can see there's an x times an x, so I'll put x squared there. And then 4x times 5 is plus 20x. That's the multiplication direction. We use that to check factoring. Now I'm going to start with that answer, or that one, and I'm going to go the other way. Pick on the small guy. The numbers that go into 4 are 1, 2, and 4. You can always ignore the 1. Both 2 and 4 go into these. You want the biggest that works, so 4. And you'll notice that there is an x all the way down, so you really want to pull out a 4 and an x. Now you pretend you're distributing. 4 times that blank has to give this front part. So we need a 3 to get to 12 and 2 of the x's to get my third x there. You can see this would be 12, and x times x times x is x cubed. Then we're going to come down here and say I need a negative 1 and another x there. And finally, you're going to say 4x times this last blank down here to get this 20x, and that would be plus 5. And you can see that that's what we started with up here when we began the process of going both directions. So here's the factored version. It's got the times in it. Okay, here's another example, and this time we're just going to start with the expression that's not factored yet. Pick on the small guy. The biggest number that goes into 12 would be 12, but 12 doesn't work. It doesn't go into 18. So then you drop down to 6, and 6 does work. But there's also an n in each of these. When there's an n all the way throughout, you're going to have to pull that out. And then you just say 6n times, it's going to have to be 2 to get to 12, and you need another n there. There's your n times n for n squared. And then you work on the back half. It's going to have to be minus 3 there, and that does it since these multiply to give that one. Now, I've got several ways of factoring this out here. This 2 goes into those, but that's not the greatest common factor. 3 is bigger. And 3 goes into these numbers, but it's not the biggest either. So the one we want is the one with the biggest possible number out there. Okay, greatest common factor. So here's another example. The numbers that go into this, you pick on the small guy. 6 is the biggest number that goes into this, but it doesn't go into 8. So then you try 3, and that doesn't go into 8. So then you try 2, and that works. So you can pull out a 2, and since there's a t all the way down, you pull out the t also. So now we just have to fill in these blanks here. 8t cubed, we need to put a 4 there to get the 8, and another pair of t's there. So now it's 8t times t times t would be t cubed. And then to get the middle one, you're going to take 2t times negative 7. That'll give you a negative 14. You've got one of the variables out here. You need another one there to get your t squared. And then we have a 2t times plus 3 here to get my 6t. And you can see that when you multiply all that out, you'll get this expression here, and that's how you check it. Okay, we're almost done with this video here. We got a little bit more here. This one here, I'm illustrating that sometimes there's no common factor. You pick on the little guy. The only numbers that divide into this are 5 and 1. You can ignore the 1. 5 works here, but 5 doesn't work there. And since there's no x all the way down, you can't pull that out either. So this one is just an example where there is no GCF. Okay, this is the first type of factoring I've taught you, and it's always the first type of factoring you try. So this is the very first thing you attempt to do, is this simple factoring out of the GCF. So you're going to pull a GCF out first whenever you can actually do it. And we'll pick up on page 3 in the next video.